Hi learners, welcome back into the other video, right, where we are still discussing about the Venn diagram. Right, so by the previous video, you'll be able to follow and be able to define what a Venn diagram is all about. Right, if you remember, we defined that a Venn diagram is simply a pictorial presentation of the relationships amongst the sets within the universal set. So you look at the relationship that exists among the sets. I'll talk of the main set, universal set, and the associated subsets of which. Like so, in the first video, by the link down here, we emphasize much on a two set problem, whereby we were drawing a Venn diagram that produced two subsets within it. Right, that's a two set problem. But somewhere you might also have a situation whereby you need to draw a Venn diagram that is connected to three subsets. So this is a category of a three set problem. So let us also have this one, and this is the last of that kind to at your level. Right, so I'll have two problems here, but specifically most of it about the Venn diagram has already defined, and what we discussed about the first category of a two set problem, it will be the same here, but rather now we just like suppose we are now having three subsets. How do we go about it? Is it different from what I've been doing? Right, so here is one of the examples. We have two on it. Like I've got some problems that we need to satisfy upon it. Right, we are like here given the Venn diagram represented by this rectangular shape. Inside it, we are going to appreciate that we have got three main minor sets, and now by analyzation, you'll be able to define these sets as the subsets of the entire set, which in this case you can symbolize it by that symbol or call it mu, like that, representing the universal set. So what we have here are just like numbers of elements which are found in a particular set of the what? Universal set. Like say number of students who go for Roman Catholic in a Form 3 class, number of students who go for what? Maybe CCP, those belong to maybe Seventh-day Adventist, those maybe belong to both. You see, we talk of the same classroom. So that same classroom is just like this one here, universal. But the students are categorized into main subsets. Roman Catholic, talk of this one of the talk of the Seventh-day Adventist. B representing the what? You can talk of another church, maybe Assemblies of God. But here now you can see that these circles are intersecting. Let's first of all discuss the intersection there, because those spaces there, the way they are, every space counts here. Right, it's basically a category of what? Members. Like say here, if you look at the space outside here, if this is about the church denomination, simply means that the four which is found outside the circle here, it means those are members who does not belong to any what of those circles. It means like say maybe if it's the class about denomination, you can say that four are members who does not go for any what church denomination. Right. If you look at 12 at this space here, you find that 12 is found in the space of what? B. So it means that 12 here, no other set from C and M is passing through this space here. So it means this C is that this 12 is representing number of elements which are just found in B only, and the same applies to 6 is C only. Look at the space. But if you talk of 7 again, also talks of what? W only. So first try to define that before we go into answering the question. That's very important each time we discuss about sets. And likely it comes to issue about Venn diagram. When you see it, first try to analyze, define the spaces to say what does this space represent, what set, what category of set are those numbers. So here, if you look at 9, you find that 9 is a space that is contained in all the three sets. Talk of set C, talk of set W, talk of set B, that are passing, or say that are around the 9. So 9 is contained in C, W, and B. So say 9 is in all the 3 sets. Right. 5 at that space tells us members who belong to C and W only. C and W only. You can see the space here is only for C and W. The same 10, C and B. Talk of 8 is W and B. At least have that analyzation of the Venn diagram. Right. So having that in mind and we have understood what all numbers they present there, now it's going down, we can maybe come down here and try to answer the question as such. So expect such questions again to come in exam, where they might give you just a Venn diagram with numbers attached, where the numbers represent the particular description of the count of a certain category of things. Then you'll be able to position to understand how many are in each and every category of those sets. Right, so like here we have the questions 1, 2, 3, 4, 5 to be answered based on that, if we're really able to follow what it means by those numbers. 1, they ask us to find N, C. Right, so from our discussion there, we know that N outside simply means the number of elements in set C. Right, so what you do here, as I said in the first video that we have just had, N simply demands you to count, only counting, it's not listing. How many are they in C? Right, so as we are to respond to the questions themselves, we'll be able to appreciate the knowledge of which will go like this. N, C simply means how many elements do you have in C. So it means you come to the Venn diagram and you focus on circle C. So if you look at C, you find the C is this circle here. Look at this, is this circle. So whatever is in C is just like split into 1, 2, 3, 4 parts. So set C has been split into 4 categories. We have got those who just get toward the C, 6, and those who are C but they're also W but they're C, 5. The 9 here who are in C, though they are also in W, they're also in B, but the parts that they're in C, that part of parcel of C. And the 10 here, it tells us those who are in C and also are in B, but they're still in C. So if we are to count how many are in C, okay, we'll be talking of 6 plus 5 plus 9 plus 10. So you write here 6 plus 5 plus 9 plus 10, and you find the answer there. So what you have is just like you have got 6 plus 5, 11, 11 plus 9, 20, 20 plus 10, you get what? 30. So that tells us the number of elements in category of set C is 20, is what? 30. Right. Let's also go to example B, where we are asked to find the number of elements in W. Right. Similarly, when it comes to Venn diagram, the skills remain the same. Focus on now a set of W, which in this case is a pictorial circle of kinds that is represented by W. Right, so you check what are the parts that have been made in W and numbers attached to it. So you find that W2 has got this category with 8 elements, and here I've got 7 elements in W only, and there are 5 found in C and W, and 9 found in C and W, and then B. Right, so still more, we go by what we have done in the first category of the problem. We're going to add 9 plus 5 plus 7 plus 8 as far as that number is contained in W. Right, so here it means number of elements in W will come from the summation of 9, 5, 7, and 8. That's it, because these are the number found in W, represented by the parts that makes W. So here we have like 9 plus 5, that gives us 14. 14 added with a 7 give us what? 14 plus 7 give us 20 what? That's 21. Then 21 plus 8 give us what? That is 29. Right, so the number of elements found in that's a talk of W, that is 29. And the same again will go to B here. We have C, number of elements in B. How many are they? Focus on B. So this is our set B. As you can see it, this is set B. Look at that one. So the number found in B are 12, 8, 9, and 10. So what do we do there? We have 9. 9 is just like it contained in all the sets. 9 plus 10, you add with what we talk of 80, then plus what? Plus 12. Right. So from that, what you have is just like 20 plus 10, 30, 39. So this gives you 39, such. Right. So that's it. So that's the way we do each time we are responding to questions related to Venn diagrams. Right. Further, we also have D here, where we ask to work out the number of elements in this symbol, which represents the universal set. So what do? You just have to add everything there. So let me just leave you this one as an assignment for you for D and E. Right? For E, number of elements in C, U, then complement W. Maybe for this one, I'll just explain a bit. Some can get confused with this one. Right, but this one is just a matter of counting the numbers, how many are there. Right, I don't know which numbers I'm going to consider. Are you going to leave anything? Something? I don't know. Try to think about it. If you talk of the investor said, which numbers are going to add there? As we are able to add for C, W, and B, which numbers are going to add here? Right? And here for E, we have, that's a C, union W complement. Right. So try again to consider about this one. When we say W complement, we are referring to what in this case? So by the W complement, as I said here, W complement, just to give you a guide, we are talking of all elements which are not contained in W as such. So which are these ones? Right. Numbers which are not contained in W. That's what it means by here. Only that this is a little bit special with this one, complement up there, combined by union with a C and the number. So try just to understand that this is a complement of W, which elements represented by complement of W, and then use it to work out for E here. Because what we're doing here is just like the same skills, just summation, summation, and summation. Right. Let's go now to example 2, the last one. So please welcome that one. Finalize. That's very direct and simple and straightforward. Don't leave it. Right. For example B, it's a little bit of application, but not difficult as far as you are able to follow what I said. Right. For B, they want us to draw the Venn diagram given the information. So still, as we said, Venn diagram should come in your head. It's just a pictorial presentation of sets. You are talking of the relationship, how they exist, like so they compare to the what? Main, which is just like an investor set. So we have information here about 3 sets, namely A, B, and C, which are splitted into such definition. And what we need here to do is simply to draw a Venn diagram and then find the possible value of X. Right. And then finally, we are asked to find the N, that's the A, intersection B, and intersection C aside. So by this time around, you are able to understand the presentation of all these symbols and the like. I don't think you have got problems now. Right, because you know what N means, just simply counting. How many are they? The apostrophes you see here, takes of complement, what is not contained in that, things like that. Now here we are, Venn diagram for part A. Right, what do? What comes in our mind first is the representation of the universal set, which comes in something like this. Representation of the universal set. That's it. So we write it here on top like that. Right. Now, we have got 3 sets, A, B, and C. But if you can look at it, you find that by the information we have down here, we are told that N is 7x plus 13, NB is 6x plus 17, NC is 8x plus 20, while A intersection B intersection C is x, NA intersection B intersection C complement is 2x, and C intersection A intersection B complement is 4x, B intersection C intersection A complement is 3x, and then we have got T, that's the A union B union C is 150. So you mathematician can interpret the meaning of that into such way that you'll be able to deduce that, say, like a number 150 here on top of A union B union C, that tells us the total number of elements in the what? In this what? Discussion. Number of elements found in A, B, and C together. No matter how B, C, and C can be splitted, but if we add the number of elements in all these sets, give us 150. That's what it means by A union B union C. So we're going to interpret this last statement by this number of elements in the universal set is equal to 150. So whatever we have here in this rectangular shape representing the universal set should be equal to 150. No matter how we split them, but at the end, the sum should be 150. Secondly, we are talking of the 3 sets here. By this statement here, look at this statement here. A intersection B intersection C. It tells us the A, B, and C have got common elements. As such, if you are going to present these minor sets here, A, B, and C, by circles, you are there likely to intersect these circles. So that at the end, you have to show a certain area that is defined by all the 3 sets. To have something like this, if this is your set, that is set A, this one must intersect with set, maybe talk of B, and then that one should also be able to intersect with another circle that is circle C. Right, so it's just like I'm considering A, B, and C as subsets of the main set, which is the universal set. It means all what I'll have in here should be equal to what? 150. Right, so this space here has made us to intersect the circles. Right, so as such, I'm going to fix in here to say number of elements in this intersection, talking of this area and begin with that, is equal to what? Is x. So here I'll write my x. Right, so what is here is just like a matter of writing all numbers of this set described by that into the Venn diagram here. So every space here must have a certain light up, either expression or a number such, which are given here. So let us now discuss as to how we can fix in these values of particular minor sets of the entire sets. Like here, this is a subset on for the entire set, because as you can see, there are several spaces. This outside space, this space here, that space, A only, B only, C only. This is just like none. Light is found in any one of the 3 sets, and here for the big part talks of what is contained in all the 3, but this one is what is found in A and B only, A and C only, C and B only, things like that. How many are they? All those are just like sections defining the what? A subsets of the entire set, which is the universal set. Right, so now for this information about X, EC features on that space, here now we go. We are told that in A, the whole of this A, number of elements in A, is equal to, we are given it as 7x plus 13. So if you look at here, the whole set here has got elements which is in total 7x plus 13. It's just an expression representing the number of elements. We can use it at least to find the exact value for that. And number of elements in B here, the whole of that one is represented by 8x plus what? 20, that is the elements in, that's now is C, right? Number of elements here, right? And number of elements in B, that one is represented by what? That's a 6x plus 17. So let's try to consider these expressions as real number themselves, right? Like say total number in those particular sets, they are represented by this type of what? Expressions. So let's put that one aside. Now here we go. For the other parts, where we might be able to see us ourselves using these numbers up there for the main subsets. Right, we are told that say A intersection B intersection complement of C is 2x. So where am I going to fix the 2x? So when I come here, I'll look at my diagram, which space is defined by this one here, A intersection B intersection C complement. Right. So here you'll be able to see that if you talk of A intersection B intersection C complement, we'll be talking of the, first of all, A intersection C, A intersection B. A intersection B is this one here, this one here. But now, if we talk of A intersection B, we're talking of this one here. But now we talk of complement of C. It means if you look at this one here, this is intersection of A and B. But now, if you can look at this one, we are also having them elements in C. But now the fact that here we are given the intersection complement of C, it means we are going to exclude this one out and we have got this one only. So what simply means here is just like we are talking of A and B only. So your 2x comes here. Right. And for this one here, we talk of C intersection A intersection B complement. The first, can you check for C intersection A? Right. C intersection A. C intersection A is this space here. This is C intersection A. Because this one, for the complement, it's just like we are excluding the B from that part of intersection. So first, look, just concentrate on, like here, A intersection B, C intersection A. Here you concentrate on what? B intersection C. If there's a part that is for A, from this intersection, you have to remove that one out. You have to remove the B. You have to remove the C. That's what it means here. Right. So like here, B intersection C, we talk of B intersection C. We are talking of this, the whole of this one. Now, in this one, B intersection C, for B intersection C, we have got A here. So it means just like we are removing the A out. So in that case, it means we have got what? We have got 3x, which has to be written at that point. Right. And after, we also have the A intersection B intersection C. The first, look at the, okay, this one has already been featured, but now let's look at this one here. C intersection A. C intersection A. Where is it? C intersection A, we talk of circle C and circle A. The intersection of A and C, it is this one here. But now with the talk of the, let's say, complement B, it means we are moving something from that intersection. Let's remove the B. It means we are going to remain with this one here. So what is different there is just like they are telling us what we want there is just the A intersection C only. We talk of A and C only, which is this one here. So for the 2x, understandably there, it's just like A intersection B only. For the 3x there, we are talking of the B intersection C only. For the talk of the other part, talk of the 4x here, it simply means we are talking of only the what? A intersection what? C only. That is for what? A intersection C only. That is for A. So that's the way you can understand this one. These are just limitations. Complement of C, complement of B, complement of A. It means in those intersections, you have to remove the areas of C, the areas of B, and the areas of A. Right. Now, having done that, now what you do is when now you can concentrate and find the values of these other spaces, which represents only what is, how many are there for B only, how many are there for A only, how many are there for what? C only. That's what we have here. So, to work out for this, and that, you can do some kind of simple mathematics, which can go something like this. Right. What I want is the A only for this part here. So you'd say now A talk of what? Number of elements in A only. This one will come from the total number of elements here should subtract what is found in A. So we talk of 4x plus x plus what? 2x. Should be subtracted from number of elements of A. Right. So for A here, we are given 7x plus 13. Right. That is the total number of elements in here. Look at this one here. And this should subtract number of elements which are found here, here, and there. So you have got 2x plus x plus 4x. Right. So this one gives you 7x plus 13 minus what we have here, it will be 7x. Like that. So when you look at this one, you have got 7x minus 7x, the answer is 13. So it means for A only here, the value here is 13 at large. Now coming for the B only, for this space here, how do I find it? I'll look at the category of B here. This B has got 1, 2, 3, 4 sections. But now the total number, it means considers this, and this. So if I'm to find this, what I have to do is just like the total number of elements in B should subtract the sum of 2x, x, and a 3x. Then I found that one up. So for B, how many are there? B were given that there are 6x plus 17. So what I'll do here, I'll do similar as I've done here, like this. Number of elements in B only. It'd be what? Total number here we are given as 6x plus 17. An expression representing the real number of the value number of things in that set. So this one should subtract what? Number of elements which are given in that B. So here we talk of 2x plus x plus what? 3x. Right. So if we simplify that, we have 6x plus 17 minus what we have there is 6x. So we have got 6x minus 6x, the answer is 17. So which means here I'm going to fix what? 17. Lastly, on that, what I'll do, I need to wake up the value of what? This space here. This simply means C only. C only. How many do I have for C only? Right. So for C only, I will use the entire circle here to say how many do you have in C as a whole. So that number of elements in C as a whole should subtract a sum of 4x and 3x. Right. So what we have is just like this. Look at this. Number of elements in C only. Right, only. How many are they in C? We have 8x plus what? 20. So represent this one as a number. This should subtract what? We are subtracting x plus 4x plus what? 3x. What do you have there? We have got 8x plus 20 minus what? 8x. So the result we have here is what? 20. So which means in C only we have got what? 20 number of elements. So look at that. It's just a problem which is just very good, and that can help us at least to analyze issues above the Venn diagram. Problems that we can solve are more like these ones here. Right, so that's the way it works here. You work out for the areas which are not given by using the total sum which you are given here for those main subsets. Right, so this is our Venn diagram. Now the other part is like to find the value of x. So for this one, I'll leave you as an assignment again. I'll just give you the guide. Looking at here, we are told that the number of elements in the investor set is 150. This has been summarized by the information down here. Number of elements in A union B union C is 150. So which means all of them, if we add all the spaces that you see inside this rectangular box, which is our Venn diagram, sums up to 150. So if now you are asked to work out the value of what? X is just as good as adding all of those what values and equate that one to what? To 150. Then you have got an equation that will give you the value of what? X. Right. So what you do here, I'll just leave you an expression, an equation of which I'll need you to work out on it, and after you use the value of X to find how many do we have in A intersection B intersection C. Right. Moreover, here we'll be talking about the same. So this question here is just like defining what we have in section A. Right. So here we have this. To find X, you talk of the X itself plus 2X plus 4X plus 3X. Right. 1, 2, 3, 4. 1, 2, 3, 4. Then you add those numbers. 13 plus 17 plus 20. And this is 150. Right. So if you add these ones out, you'll be able to find the value of X here as something else. So I'll leave you to finalize that one out. And for B, the X that you're going to find, you'll be able to see that the value that you find here for X is the same that is referred to B here. Because in B, we're talking of A intersection B intersection C. So for A intersection B intersection B, it is the same value which is X here. It is this space here. So if you find the value of F, it means you are also responding to number of elements in A intersection B intersection C as such. Right. So by this, I know your students, you are using brain, you can be able to handle that very well and finalize this example. Right. So by this, let me call it a day. Right. And always requesting you, as learners, try at least to revise this, what we are discussing here. They are featuring the reality of what happened in the syllabus and the expectation of what you have in exams. Right, so I always urge you to replay these videos now and again. Go back by the link that we have down here. Start later away from the beginning, definition of essays, go on. If you don't understand, replay the videos now and again. Right, where maybe problems will still be there, you are always free to ask, and we're going to attend it to you.